Hi everyone, this is your struggling CS student here, and today I'll be solving another problem of the day. So let's take a look at today's problem. Seems easy enough. 11 rated 1100 only. So today's problem 2011. Find a value of a variable after performing operations. There is a programming language with only 4 operations and one variable x. Okay, you can either do a pre-increment or post-increment. Yep, same thing here. You can do pre. This is pre. Oh my god, I don't remember. This is pre-decrement, this is post-decrement. Yep. So initially the value is x given an array of string operations containing a list. Yeah, this is pre, this is post. Okay. Containing a list of operations, return the final value of x after performing all the operations. So you minus, you plus, you plus. You plus, you plus, you plus, you plus, plus, minus, minus. I'm trying to think if like the pre and post decrement actually matters. It doesn't really matter in this case, right? Because yeah, it doesn't really matter in this case because it's not like, yeah, I mean, so I guess simple enough, you just iterate through the operations, you just keep track of um the value x, and that should be good. I'm trying to think if the pre and post actually makes a difference. I don't think it does. Yeah. Okay, so what do I mean by that? So if let's say you have like a variable, I mean in Python, it actually doesn't really matter. So if let's say, but like in other languages, maybe like C++ or in Java. So let's say you have an int x is equals to like some value 10, right? And then you say y is equals to like plus plus x x. What happens is the pre-increment operation happens first, and then it assigns it to the value of x. So in this case, um, y would actually be equals to 11, and x would also be equals to 11, I think. So if you don't do this, then the other alternative is like if your in y is equals to x plus plus, what happens is this uses the variable first and then increments x. So in this case, you get y is equals to 10, and then your x would be equals to 11, I think. So actually, I want to like confirm this now. Okay, but this is not the purpose of the video, so I would just you can check this in an online compiler, but I'll just solve the problem. In this case, it's quite easy. X is equals to 0, you will return x. So you say for operations in for op in operations, right? So we say if op is equals to or op is equals to this, we can just increment x by 1. X plus equals 1, else x minus equals 1. Okay. Oh, I didn't change this. No wonder. Yeah, I think that should be it. There's nothing more to it. Wait, what did I do? Oh, I accidentally deleted it. Okay, I'm just give it a submit. Okay, it passes. Today's question is super duper easy. But yeah, thanks for watching. And you know what? Maybe the problem is so easy. I'm gonna do another random question. Yeah, let's do another random question. This is not a good practice. So just do a random question. Let's see. Maximize distance to closest person. Okay, 1300 question. Rated 1300. Probably not that bad. Okay, you're given an array representing a row of seats where seats of I is equals to 1, representing a person sitting on the ith seat. So if seats of I is equal to 0 means that seat is empty. So there is at least one empty seat and at least a person sitting. So I'm expecting seats to be at least length of 2. Yeah, okay. Alex wants to sit in the seat such that the distance between him and the closest person is maximized. Return the maximum distance to the closest person. Ah, okay. Okay. To the okay. I mean, yeah, it's not that bad. So what I'm thinking of is like we can either yeah, I think we can just iterate through seats, right? We find the what's that? We find like all the people, all the seats that have been taken by somebody. Okay, then we can just calculate the gap between them, and we can just calculate the distance and take the maximum result in this case. So in this case, we can see like, oh, the gap between the first and the second person is actually 4. So in this case, we want to see in the middle seat. So we just take 4 divided by 2, and that should be good. Likewise here, in this case, the distance, so it's like 6 minus 4 divided by 2. Well, distance is only 1. So in this case, here, the distance 2 will be the answer, right? In this case, because we actually can't find, so we need to handle this edge case where if we can't find, maybe we need to use like a sentinel value. Yeah, yeah, maybe we can use like a sentinel value. If not, we have to handle the case where there's only one seat. So how do you want to do the sentinel value? Maybe we just add it, maybe our taken, we just add like -1, or let me see. Sentinel value. How should we do this? Or maybe I shouldn't try to be too smart about it. Let me see. Basically, we're just interested in the gaps in this case, right? So we do want a value here. We do want a value here. Should I just put -1 and n? Is that good enough? Is that good enough? I think that's good enough. Then you just take the absolute difference between them, right? Yeah. Okay. Yeah, I think that's good enough. So for such as taken is an array, and we'll do -1. And then for as in seats, we would say if seat is equals to 1, that means the seat is taken. Then we'll actually want to append the index in this case. So we can get the index when we enumerate seats. So enumerate. Okay. Then afterwards, we just need to care about the gaps between them, right? So we say best is equals to 0 for I in range from 1 to length taken. We would say best is equals to max of, well, the current is equals to taken of, taken of I. Then we say previous is equals to taken of I minus 1. So best equals to max of best of absolute difference between current minus, let's think about this a little bit more carefully. Because if we take 0 minus minus 1, or maybe I'll just shift it up by 1. Yeah, maybe that's a little bit easier if I just shift it up by 1 instead. So we say starting from 0 plus 1, and then in this case I still need to at the end taken dot append n plus 1, right? So these two are sentinel values, this and this. Let's see. 0, 1, 1, 2, 3, 4, 5, 6, 7. And that's 1, 2, 3, 4, 5, 6, 7. Yep, okay. So that then we take current and previous, absolute difference between current and previous, and then we'll return best. I think this should be good enough. Oh, and it's not defined. Sure, this is the length of seats. Oh no, that is not good. Oh, that's because I didn't divide by 2. Okay. Divide by 2. Okay, let's see. Let's see taken. Yeah, this is probably like some off by 1 error. So in this case, I have 0, 1, and 5. So answer is 3. Oh, because it's like 1, 2, 3, right? Because we can see it here. And 2. Oh, never mind. Actually, we can't use sentinel values in this case. Yeah. Oh, yeah. We actually can't. Maybe we, because in this case, right, where it went wrong is because we assume that there is a like an empty seat here that's like outside the bounds of the array. I mean, like treat it as it's being taken. So the algorithm actually thinks that, okay, actually this is the best seat, but actually we know that this is the best seat. So no, this is actually no good. The sentinel values didn't actually help us. So maybe I was just trying to be too smart about this question. Oh my god, that is embarrassing for a only 1400 rated question. Okay, so how should we do this? Index seed taken, estimate taken, current and previous. We're just interested in the gaps. But if there's only one seed, then we don't actually want to take the middle, which is, if it's only one seed, I guess we can just handle the special case, which is like not very, how should I say, it's not the prettiest solution, but sure, whatever. So if length of taken is equals to 1, then we handle the special case here, right? So we say we either sit at one end or the other end. So we return max taken 0. Yeah, I guess we can still take the absolute taken minus 0, or absolute taken, we do n minus taken. And just to make n available, we would say n is equal to length of seats. Is it n or n minus 1? It might be n minus 1. Oh, what's wrong with this? Okay, it's n minus 1. Wait, is it? Oh my god. Wait, it's still not it. Shit. Length of taken. Oh, shit. Okay. Yeah, I need to do that instead. Okay, let's see here. 4. Because it's 0 minus 0 or n minus 1. No, come on. Don't tell me. Yeah, okay. I was a little bit worried that it's gonna be this one correct and this one wrong. Like this. Okay. Seems okay. What's the time complexity here? Time complexity is On. We do one loop here through seats where n is the number of elements in seats. Then here it's also bounded by On if let's say every seat is taken. In terms of space complexity is also On because we have to keep track of the indices that are yeah, the indices of the seats that are being taken. So that will take up ON space if let's say every seat is taken. So let's give this a submit. It should be good. Oh no, that is not good. The output is 1. Oh, that's because we can sit at the corners. Ah, okay. I see now. So instead of handling the special case here, we just need to incorporate it into our checks here. Oh, it is. Okay, fine. I think we can just let's say this is what seat at corner. Then just need to maximize it. Best and seat at corner. What if the corner seat is already taken? Right, what if the corner seat is already taken? Then we can't sit there actually, right? Should I be careful about that? Okay, let's be careful about that. Let's not try to be too clever. So seat at corner is equal to 0. So if taken, 0 is not equal to 0. So it's not equal to 0. That means that that seat is not taken. We can sit there. So let's do that. Right. Else, seat at corner is equal to max. It's a double if statement actually. Yeah. Seat at corner is equals to the max of seat at corner. Like this. This is the next check. Okay, so if taken minus 1 is not equals to n minus 1, then we can maximize it again. Okay, that is horrible. In the actual interview, I would have been already cooked. Because like all these edge cases that you don't think about. Okay, let's give it a spin. What? Wait a second. Oh shit, okay, shit. This is not taken off 0, this is taken off at minus 1, right? Okay, 2 wrong submissions. That is absolutely horrible. Okay, yeah. Let's see. 2 wrong submissions. But what does the editorial say? The next array I don't know what's going on here. Two pointer. We update the closest person sitting on our left and the closest person sitting on our right. How do you keep track of the person sitting to your right though? So people, eye for eye, if seats, okay. Oh, oh, okay. That's kind of cool. So for the seat, if it's a seat, you set the previous. Otherwise, while future is not none, and future is less than I, is next to people or none. Oh, never thought of using an iterator. So yeah, this is kind of a cool solution. Group by zero. Answer is set of index one. Okay. Group by seats. Okay, I'm not sure what's going on here. That's true. Let's see, what is this trying to do? This is probably what I'm trying to do. But that's actually a one solution. Okay, that's kind of cool. But yeah, that's it for me today. Thank you for watching and happy grinding.